We're going to be working with unit circles with domain, and we're going to start with problem A here. So we see it's cosine 41 over 56. So we're going to start by drawing a unit circle. Since it's cosine and it's positive, we know it's going to be on this side of the unit circle. So now, take our calculator and do the inverse cosine with the same numbers here. And you get your answer equals 0.749. So now we can subtract that from 2 pi, and we're subtracting it from 2 pi because it's cosine. And you see what I did there is I used my answer from up here, and I just pressed the answer key to get that. So your final answer in this instance would be 5.534. And we're rounding up on that last 3 to a 4 because there's an 8 after it. That would be your final answer for A. Moving on to B. It's essentially the same concept. You start with your unit circle, and it's positive because it's a positive number here. Now you're going to want to take the inverse of your sine and the same numbers. Cool. Now we're going to subtract from pi because we're using sine here. So this would be your final answer. And I'll explain a bit why we're subtracting from pi. Since we're using sine, this is pi, and sine is up here, so we're not necessarily worried about the areas down here. That's 2 pi. So we're only worried about 2 pi in these areas when we're dealing with cosine. So when you're using cosine, you're using 2 pi, and when you're using sine, you're using pi. Okay. Now you see here we have this concept of negative numbers. So start the same way. We'll draw our unit circle. And since there's a negative here, we know it's going to be on the negative side of the unit circle. So, and I completely forgot to mention, this whole time we've had these domains here. Now, for these problems, these domains haven't meant anything since we're going from 0 to pi, also to 2 pi, and it can equal them, meaning none of the circle is off limits. So whatever answer you get can be within the circle, and that's acceptable. Okay, back to C. We'll start the same way we've been doing it. We have our unit circle already, and we'll take the inverse of cosine, negative 22 divided by 37. It's 2.208. Go ahead and write that down for you. 2.208. And now we're going to want to subtract that from 2 pi, and on my calculator you'll see 2 pi minus answer. 4.056. 0756, excuse me. 4.076. That's your final answer. 4.076. I'm so sorry. Okay. With D, you see something similar again. You see a negative sign. And that tells us it's going to be down here on the negative y-axis of our unit circle. So, same process. Inverse sine, negative 3 divided by 7 equals negative 0.443. So this is a little different. Since we're subtracting from pi, since we're using sine, we're going to want to do pi plus answer, because our answer is negative. Cool. That should be final answer. Now E's kind of special, and I'll show you why. So we'll see here that we need to balance this equation because you can't do anything with it in this state. So we're going to want to take 65 and subtract it from both sides of the equation. Minus 65, minus 65. Because I'm lazy, I'm going to do it on my calculator. Negative 24. Now we'll need the 22 over there, so we'll divide by 22 on both sides. Negative 24 over 22. See, but this is where it gets different. If you take your calculator and you do inverse cosine negative 24 divided by 22, you'll get an error. And the reason as to why is pretty simple. If you look at negative 24 divided by 22, and we plug that into our calculator, that's more than 1. Even if it's negative, it's over 1, meaning it's exceeding all sides of the unit circle. It's not in the unit circle. So in this instance, it's no solution. Okay. So that's page 1. Okay, so page 2. Let's go ahead and start. We already have some information that we know how to work with. So like always, we'll draw our unit circle. Then we're going to balance our equation. We're going to want to take 74 out of both sides of the equation. We'll do 60 minus 74. That's negative 14. That would divide by 32 on both sides. And you're left with cosine theta equals negative 14 over 32. So now we take the inverse cosine, negative 14 divided by 32, and we get 2.024. See, what sets page 2 apart here is that we have these different domains, and we're going to want to be very careful of those. So let me explain where these apply. This is positive cosine. Excuse me, this is negative cosine. So our answer is going to be somewhere over here. But because of this domain, our answer must be within this part of the circle. Because pi to 2 pi, or excuse me, your answer cannot be in the indicated part of the circle. Because pi to 2 pi is down here. So the answer must be somewhere down here. So let me go ahead and get rid of that line because it is confusing. So your answer must lie in the lower part of your unit circle because your domain ranges from pi to 2 pi. So after we've made this calculation, we have found this length of the circle. And we can infer that because this is 0 and this is roughly 3.14. So because 3.14 divided by 2 equals 1.57, that would make this area right here 1.57, putting 2.02 roughly right there. So that's how we can infer that our answer is correct and where our answer lies, where our answer would be on the circle. So it's cosine, so we'll be using 2 pi, and we're subtracting. Ooh, whoopsie daisy. Hold on, let me take a few steps back. That's too many steps back. No matter. Inverse cosine, negative 14 divided by 32 equals that. 2 pi minus answer 4.2. So got some different rounding here. 260. Cool. Because we're going to the thousandths place when we round on our answers. So this should be your final answer for 2A. And I'll make the next one cleaner because some of these lines are really confusing. So we're working with sine. We got minus 80, 42 sine theta equals 12. Divided by 42, divided by 42. So you see here, this is just a different method. You can plug in inverse sine 12 divided by 42, and you'll get the same answer. Oh. That's interesting. Ooh, my apology. I was throwing for a loop because the two numbers are just very similar. You can throw that into your calculator and you'll get the same answer, but you can also do 12 divided by 42, then do the inverse sine of that, and you'll get the same answer that way. So we have 0.28. Oh no, 0.290 because of rounding. Okay, and since we're using sine, we're going to want to subtract that from pi. Second, pi minus answer, 2.852. And I skipped the unit circle here. It's not like we really needed it, but we actually really do, because this one has a domain. So since this one has a domain, and it stretches from pi over 2 to pi, meaning that our answers must lie within this sector. And we're working with sine, and we're working with positive sine, so our answers would be up here, and all of this area is out of the question because it's not within the sector pi over 2 to pi. Luckily for us, our answer lies within that area. If this is 0, and that's 3.14, we can infer that 2.852 is somewhere in there. Alright, so you'll see here that I modeled all the locations on the circle for you, just as a little help. This point on the circle, the starting point, is 0, but it's also simultaneously 2 pi. When you go a couple rotations around the circle, you get back to that point, 2 pi. You go up one section, or 90 degrees, that's pi over 2, another 90 degrees, pi, another 3 pi over 2, another, you get back to 2 pi. So I want you to go ahead and try to solve all these 4 problems. Remember the domain. I'll post a picture of the solutions at the end of the video. So a quick side note, when you're placing your lines on your unit circles, when using cosine, put them to the left and the right, depending on whether they're positive and negative, and sine goes on top or bottom, depending on positive or negative.